Limiting reactants stoichiometry. Often reactants in a chemical reactions are not reacted in perfect molar ratios to each other. And because of this, you're going to end up with one or more, depending on how many reactants there are, of those reactants being in excess. So the stoichiometry questions, they may only give you one number, and if there are other reactants and they say they're in excess, you only have to worry about that one number. However, in a limiting reactant stoichiometry question, they're going to give you the amounts of the other reactants, and it is up to you to find out which one gets completely used up. That's the one that's limiting, and the other ones themselves will prove to be in excess. So when given the amounts of more than one reactant, you must determine which one is the limiting reactant. This may not be clear in the question itself, but it has to be clear based on the data that's given to you. If they give you more than one amount of reactant, you have to find out which one's limiting, which one's going to run out. The limiting reactant is the reactant that produces the least amount of product. So it is one that produces the least amount of product. It is not necessarily the reactant in which there is the least amount of. So you might have some reactants and they're going to have certain quantities to them. The limiting reactant is not necessarily the one which there is the least of. It is definitely the one that produces the least amount of product. So if you want to know which one's limiting, you've got to find out how much product does each one of them produce. So these types of questions are going to involve you doing multiple sets of calculation and then finding out which one can produce the least amount of product. Here's the example question here. So given the equation, unbalanced, what mass of aluminum iodide would be produced if 2.7 grams of aluminum, so we have 2.70 grams of aluminum and 25.4 grams of iodine gas. So clearly there's not as much aluminum by mass as there is of iodine gas, or iodine solid in this case, sorry. There's definitely less aluminum by mass, but just because there's less aluminum doesn't mean that's limiting reactant. The fact is we have two amounts to consider, so we have to calculate out how much product would we get from the aluminum, how much product would we get from the iodine, and which one of them produces the least amount of product. That one will be the limiting reactant, and that one will give us the actual amount of product produced by stoichiometry. So stepwise, first off, we have to have a balanced chemical equation. So pause the video, balance the equation. Once we have a balanced chemical equation, we are going to start our calculation. So we're going to calculate the limiting reactant, how much product, in this case we only have one product to worry about, but if we had more than one product, you just solve for one or the other. And how much would actually be made from each of the reactants. So we'll have to do two sets of calculation. For each set, we're going to convert to the number of moles in order to use the mole ratio from the balanced chemical equation. We are then going to apply that ratio so we can find the amount of product we're looking for. And then we're going to convert to whatever units asked for. If it was asking for moles, we'd be done after step 3. If they're asking for mass, then we've got to convert to mass of the product using its molar mass. Remember that the reactant producing the least amount of product is the limiting reactant. One of those two reactants is going to run out first. That's the limiting reactant. That's the amount of product that we could possibly produce. Make sure you state your answer, because by doing this set of calculation twice, we're obviously going to get two answers out of it. So we have to make sure we state which one is the actual answer, and then cross off the one that is the non-answer, the one that does not actually get made. So let's try it out. Here's your balanced chemical equation from before. You should set this up in two parts. We're going to do one set of calculation for aluminum. We're going to do one set of calculation for iodine. So set up two separate lines in your calculations. We're going to start with the mass of the aluminum and do its set of calculation in one part. And then we're going to start with the mass of the iodine and do its set of calculation in the other part. Both of these will give us a mass of product produced. So we're going to convert the mass of aluminum to moles, and then to moles of aluminum iodide, and then to mass of aluminum iodide. And we're also going to do the same thing for the I2. Find out how much product it can produce. So we will end up with two different answers from our two sets of calculation, and then we have to state which one is the correct answer. So first off, you should be able to do this part on your own. This is the same stoichiometry we were doing before. We're starting with a mass of aluminum, and we're going to take that mass of aluminum and convert it over to a mass of aluminum iodide. So pause the video at this point and find out how much aluminum iodide in grams could be made from 2.7 grams of aluminum. First step, convert mass to moles of aluminum. So mass cancels out. Then we're in moles of aluminum. We then have to use our next conversion factor that will cancel out moles of aluminum. So we'll be in moles of aluminum iodide. And again, these are coming from the balanced chemical equation. For every 2 moles of aluminum that is used, there will be 2 moles of aluminum iodide produced. Then our question's asking for what mass of product it is, so we have to get rid of moles of aluminum iodide and convert to grams of aluminum iodide. So you should have had that set up. Every conversion factor, you're going to write the units in there as well, write the labels on there because we're converting between different substances and you don't want to mix them up. You should have gotten 40.80 grams of aluminum iodide. Again, I'm going to carry 4 significant digits. I know I'm going to have to answer in 3, but until I get to my final answer, I'll carry 1 extra significant digit. So if I used all of my aluminum, I would produce from that aluminum 40.80 grams of aluminum iodide. However, I might not be able to make that much product. I've got to see how much product I can make from the iodine itself. So again, pause the video, do the same calculation for aluminum iodide. Take your mass of aluminum iodide and convert to the mass of, take the mass of iodide and convert to mass of aluminum iodide and find out how much you get. The first step would be to set up a conversion factor that will cancel out grams of iodine. So we use the molar mass of iodine to get us to moles of iodine. We would then set up our next conversion factor so that we can get to from moles of iodine to moles of aluminum iodide. So that is our 2 to 3 ratio, or 3 moles of iodide from here to 2 moles of aluminum iodide on top. So we are now in moles of aluminum iodide. We then want our answer in mass, so I'm going to use the molar mass, which we already calculated earlier, so that's an easy one to do. So grams of iodide are cancelled out, moles of iodide are cancelled out, moles of aluminum iodide cancel out, and our final answer, like above, will be in grams of aluminum iodide, which works out to be 27.2 grams of aluminum iodide. Now, we've got 2 answers here. You can't leave a question with 2 different answers. There's only one right answer. The one that produces the least amount of product, which was the iodine, is the limiting reactant. We can only make 27.2 grams of aluminum iodide. We would never be able to get to 40.8 because as soon as we get to 27.2, if we tried to make 27.3, we wouldn't have any more iodine left over. It is limiting. It's the limiting reactant. So the most amount of product you can make is 27.2 grams. Cross off the 40.08. It is not a real answer. You cannot make that much product. You could only make 27.2. So conclude with some sort of statement to that regard.